You are welcome, everyone. Today we are going to be looking at the modulus of vector in terms of its components. We are going to be looking at two components and three components. But first and foremost, we need to look at how vector components looks like. Two components and its three components. Now, a two-component vector looks like this. Vector R equal to xi plus yj. So it's having two components like this. That's component I and component j. So in this case, the components are the horizontal and the vertical components. While a three-component vector can be written as vector R is equal to xi plus yj plus zk. So it's having the I component, the j component, and the k component. Also, vector in terms of a component can also be written in column vector. And two component with column vector is written as vector R x, then you have y. This is two component vector, R equal to. Then we have three component vector in column vector. It's going to be written as R equal to x, y, and z, like this. So these are the ways that we write component vectors, either in two components or in three components. Now, what are we going to quickly look into? So the modulus of vector is given as, so let's say vector R is given as R is equal to xi plus yj. So the modulus of vector R is represented as the absolute value of R, just like this. This is how we write it. And it's going to be equal to the square root of x squared. X is a number, in this case, plus y squared. In this case, y could also be any number, either negative or positive number. So that is what x and y are representing. And this is for two components. Now, if you want to get the modulus or the magnitude of a vector which is in three components, it's going to be the magnitude of R or the modulus of R. They mean the same thing, equal to the square root of x squared plus y squared plus z squared. So you can see they are all the same. So the only difference is the first one is having just two components, while the second one is having three components. Now let's quickly take some examples that we can quickly look into. The first example here says that we should find the modulus, or find the modulus of 1, 3i plus 4j, 3i plus 4j. And the second one is that we should find modulus of I plus 3j. The third question says we should find the modulus of I sine theta minus j sine theta. Okay, j cos theta rather. J cos theta. J cos theta. So we are going to be using the formula that I've given you to find the modulus of this. We can also call it the magnitude of this. So modulus and magnitude, they are the same. Now, how do we go about this solution? The first one, given that R is 3I plus 4J. And how do we go about it? The modulus of R is giving us the square root of x squared plus y squared. This is just two component vector. And in this case, our x is 3 and our y is 4. And that should be the square root of 3 squared plus 4 squared. And that's the square root of 16 plus 9. That's 9 plus 16. And that's the square root of 25. And what's the square root of 25, guys? Square root of 25 is just 5. So the magnitude or the modulus of the first question given to us is 5. Now let's quickly look into the second question that says I plus 3j. Number 2. R is equal to I plus 3j. We already know that the modulus of R is giving us the square root of x squared and plus y squared. So in this case, our s is the coefficient of I here, which is 1, while our y is the coefficient of j, which is 3. So, and that's going to be square root of 1 squared plus 3 squared. And that's the square root of 1 squared is 1 plus 3 squared is 9. And that gives us the square root of what? 10. So I'm going to leave my answer as the square root of 10. And the third question says we should find the modulus of I sine theta. So this time, R is I sine theta minus J cos theta. J cos theta. So we are using the same procedure. The magnitude or the modulus of R is giving us x squared plus y squared. And that is going to be equal to the square root of, so in this case, our x is sine theta, our y rather, is minus cos theta. So we have sine square theta, so we call it sine square theta instead of saying sine theta squared. So avoid confusion, so we say sine square theta. Because if you say sine theta squared, people will think it is the theta that owns the square. So instead, sine theta times another sine theta is pronounced as sine square theta. So plus our y is minus cos theta. So minus cos squared theta this time around. So instead of cos theta squared. So to avoid the same confusion. So we have sine square theta plus, open your bracket, minus cos square theta. And this is going to give us the square root of sine square theta plus, because when you multiply negative twice, minus times minus is definitely going to give you plus. So that's why we have plus cos squared theta. So sine square theta plus cos square theta, if you try to remember when you were doing trigonometric identities, recall from trigonometric identities that sine square theta plus cos square theta equal to 1. So all we just need to do is replace everything that we have here with 1, because sine square theta plus cos square theta is 1. So hence, the modulus or the magnitude of R is the square root of 1. And the square root of 1 still remains 1. So the answer to this is 1. So all these examples that we have just treated, they are just examples under 2 components. Now let's quickly look at few examples under 3 components. Example. Now find the magnitude or the modulus. Find the magnitude of 1. 3i plus 2j minus 5k, and 2, 4i minus 3j minus 2k. So you're going to be using the same procedure to get the first one done. So let's agree that r equal to 3i plus 2j minus 5k. And the modulus of r is given as the square root of x squared plus y squared plus z squared. And in this case, x is 3, I is 2, and z is minus 5. So we have the square root of 3 squared plus 2 squared plus, open your bracket, minus 5 squared. Please don't make mistake. So we have the square root of 3 squared is 9 plus square root of 2 squared is what? Is 4. Then square root of the square of minus 5, rather. Minus 5 times minus 5 is definitely going to give us 25, not minus 25. Why? Because minus is going to multiply itself twice. So minus times minus automatically becomes plus. We have plus 25. And when we add all of this together, the modulus of r in this case is 9 plus 4, 13. 13 plus 25 is 38. So we have the square root of 38 as our answer. Now I'm going to repeat the same procedure for the second one, which says that r is 4i minus 3j minus 2k. And we already know that r, modulus of r, is the square root of x squared plus y squared, then plus z squared. So which is going to be equal to the square root of, in this case, our x is 4. So we have 4 squared plus y is minus 3. So open your bracket, minus 3 squared. While z is minus 2. So plus, open bracket again, minus 2 squared. So when we add this together, we have the square root of 4 squared is 16. Minus times minus will definitely give us plus. So minus 3 squared is plus 9. The same thing with minus 2. Minus times minus will give us plus. So minus 2 squared will give us plus 4. Now adding all this together, we have the modulus or the magnitude of r is the square root of 16 plus 9 is 25. And 25 plus 4 remains 29. So the answer here is the square root of 29.